Okay. Good morning, everyone. Today we are going to discuss on the topic of operators. Okay. Yesterday we completed with the data types, variables, input reading, dynamic input reading, and the print statements. Today we are going to discuss the operators. Before going to discuss on the operators, first you have to know the project structure of a Java. Okay. I have to discuss first, but I have to continue the some topics before that. Normally, if you are using the any IDE of a Eclipse or a IntelliJ like that, it has some project structure. First, you have to create a Java project. In that Java project, you have to create the packages. Under the packages, you have to create a class. Like the same way, how can you create here for the in a VS Code also? Okay. First, we can discuss the project structure of the Java. Or Java project structure. Why it is important is normally you can run the programs by creating a folder and all the things, but we can discussing some topics of the access modifiers and the range of the variable scopes and all the things. Then packages can be helps to you better understanding, and also when you are dealing with the AEM backend code, it will be stored with the package names. Okay. In the Java project structure, first one was a project name or a project. Okay. First one is a project. Under this project, okay, project name. Under this project, you have a package. Under this package, you have a classes. Under this class, you have the methods. Project. Under the project, you have the packages, classes, and the methods. Normally, method is nothing but a some particular code, some block of code for the some particular functionality. Suppose I have a method 1, method 2 can be wrapping by a one class. Suppose I have a class 1 have the method 1 and the method 2, and I have a class 2. Okay, this class 2 have also the method 3 and the method 4. These class 1 and class 2 under the same package. Okay, like that I can create another package in the same project. Package is nothing but a collection of classes or the combination of a classes. All the classes you can group in a one module, it will be the package. And class is nothing but a collection of methods. Okay, method is nothing but a block of code. Suppose you are seeing the main method. Main is one method. It contains some block of code or some block of logic. This will consider under a class. That class will be in one package. Suppose it is a package 1. It contains class 1 and the okay. Suppose I have a project of a project 1. Okay. Under this project 1, I have a package 1. Package 1. Under this, I have a one class 1. And I have a one method of a main method or anything, method 1. And also have a method 2. Method is nothing but a block of code, like a simply example main. In the main method, you can write some logic rates, suppose for reading a value or printing something value. It was one block of code, some particular task. Like that, you can write some methods. The same way, I have another class. It is a class 2. Okay, suppose this method already in a class 1, then I can reuse this method in the class 2. By using the packages and the classes, I can reuse it. That is the purpose of you can using the packages and all. Suppose I have a new method, I can easily create, or else if already the method exists, I can directly call method 1, call from class 1. Directly I can use what I can use in the method 1 without writing of the rewrite of a code. Same way, I have another package. Suppose what is the class 1 I have to use in a other package also. Then in a package 2 I want to use the class 1 and the class 2. Directly I can import that from the package 1 to the package 2, that class, and I can use it. That is the purpose of the maintaining the packages and the classes in a one project directory. Okay, first, how can we create a Java project in a VS Code? Suppose if you are click on a file, okay, suppose if you are in a empty file directory, you can see an option of file here. You can click on create a Java project, or else here you can get a one Java project. Here you can get the one Java project option. Click on that, or else Control Shift P. Click on the Control Shift P. Noble Tools, I think. Or else you can create outside of the project. One way is you can click on here. Suppose you want to open a folder or create a Java project, click on the create Java project. Click the Noble Tools. Here you can search for or if you want to create a new one, create a first folder where these projects has to be stored. You can create a Java project. First you have to mention where that project has to be stored. Suppose my project has to be stored in a January Java batch. Suppose I can create a package or a folder. It was a location where I have to show. Select the project location. Here you can define a name for your Java project. Here it will ask for the Java project name. My Java project name is suppose Java learning is my Java project. Okay. Click on enter. It will create a basic structure. It will create a basic structure with some small app of a Java. Okay. Small app. It is a one class file. It is under the folder of SRC. Okay. SRC is the main folder where you have to write these packages and classes. Wait a minute. Okay, this is the way you can create a project. Suppose under this project you want to create a package. Under this project you want to create a package, or else you want to remove this app. First you can remove this app. You can remove by using the delete. Okay. How can you create a packages? Normally the packages are under the SRC folder, source folder. Right click here, new Java package. When you right click on the SRC, you can get an option of a new Java package. You can enter the package name. Normally the package's name will be with a com dot something like that. You can use the any different name also. Normally you are go with the any other project structure also in a real world projects. They are using the same com. Common is like a common. Com is like a common. You can use com dot suppose com dot Jan. Okay, com dot Jan is my or January is my package name what I am creating. Okay, after that it will create a one folder as a com, okay, and January. Okay, it will create a folder. In this you want to create you want to create a class file. Here you have an option of new Java file. Here you can choose the class file, or else you can go with the new file. My new file is as suppose today we are going to discuss operators, right? Arithmetic operator. Dot Java. Arithmetic operator dot Java. Suppose you want to create another package, okay? Then right click on again src, new package, com dot December. If you observe, it will create under the com one December, one Java folder. Nothing but a folders. Package is nothing but a one folder. Collection the all the class file. January contains the arithmetic operator .java one thing. Suppose I can create another file. Here I can create a class. My class is suppose after that relational operator. You can just enter, it will create with a .java extension. Why? Because I am choose the class file to create a class file, okay? And here you want to mention a main method, then you can mention here, okay? This is the way. Suppose you want to use this arithmetic operator.java in a December file, then you can import this arithmetic operator class file in the December folder, then you can access it. Okay, this is the way you can create the package and the classes under the package. First you can create a package, traverse to the package and right click there, you have to be give. Okay, clear? Now simply we'll go with the next topic of operators. This is the way you can create a package. You can understand when we are moving to the different topics, what was the purpose of a packages and what was the need. I think the next class, maybe in the next class or in the next session or day after that session, we can discussing one topic of access modifiers. There you can easily understand what is the purpose of the packages and all. Okay. When we are go with the OOPS concepts also, it is better understand to you. Okay. In the operators, what are the operators we have? Operator is nothing but a performing an operation. Operator helps to perform an operation on a variables or on two variables. Operator helps to perform an operation on two variables. Helps to perform operation on two variables. Operator helps to perform an operation on two variables. Here you have to understand the, suppose operands and operator, there are the two terms here, operands and operator. Operands are nothing but a variables, that means on which we are performing the operation. On which we are performing the operation, they are calling as a operands. What the operation you are performing, for that you are using one key or one item, that will be an operator. Suppose a plus b is one operation. What is the operation? Addition operation. In that a and b are the operands. A and b are the operands. Plus is the operator. This entire thing will be the operation. Operands, operator and operation. Operands on which you are performing operation. For example, a comma b. Okay. And the same way, operator key used to perform operation. It was a plus example here, like above example plus. Terminology is important, operands and operator. Okay. Next, what are the different operators we have? Okay, what are the different categories of operators we have? First one, we have the different categories, I think almost 7 to 8. First one will be the arithmetic operators. Arithmetic operators. Arithmetic operators are nothing but you want to perform mathematical relation operations. Arithmetic operator helps to you. In that arithmetic operators, what we are already know, like a plus, okay, addition, addition. For that you have to use the plus symbol, right? The same way for the subtraction, addition, subtraction, multiplication. For that you have to use the star. For the subtraction you can use the minus, the same thing, and division. For the division you have to use the slash symbol. Okay. Next, important one, modulus. Modulus operator. For that you have to use the percentage symbol. Modulus operator you have to use the percentage symbol. Okay. The major operator is a modulus operator. Okay. Normally you can see, you can know addition, subtraction, multiplication. A plus b, a into b, a minus b, right? A by b. Okay. In the division operator, always the result will be the quotient. Result always be the quotient. It will be depends. That means suppose in a scenario I can take a variable int a, okay, int a equals to 10, suppose. The same way int b equals to 12, okay, int c equals to a by b. Then what will be the c value here? Okay. What will be the c value? The c value will be the, normally the value what exactly divisible is 3.333, right? But here it will takes the 3. Why? Because I am storing it as a int type. I am storing it as a int type, so it will taking as a 3. Suppose int, so okay, if I am taking the float value, float c equals to a by b, then the result will be the 3.33. Okay, up to how many decimals? It will be 6. Why? Because float is right, so float will be the 6 decimals, 3.333. It depends on the data type of the value you are storing. Suppose if I directly write in a print statement, sys out of sysout, that means system.out.println of c, system.out.println of a by b, then also the result will be the 3.333. If you are storing that with the integer only, it will takes the, what the value? That means quotient. No, right? The result always be the quotient means sometimes always be the quotient. Okay, it will be depends on the data type of the variable you are storing. The same way, modulus operator. Modulus operator helps to getting the remainder values. Suppose if you want to check a number is even or odd, how can you check? Suppose what are the even numbers? The even numbers will be the 0, 2, 4, 6, 8, 10. How it will be tell? Which is exactly divisible by 2. Exactly divisible means the remainder is 0, right? If you want to check a number is an even, you want to know that remainder of the particular number when you are divided with a 2 is 0 or not, right? Suppose when I divide 3 by 2, if I am getting the remainder as 1, then only I can tell that it was a even number or odd number based on the remainder, right? For that you want to know how to check a remainder, right? Modulus operator helps to know the remainder values. Okay, suppose I can do with a lots of scenario of the cases we are using the modulus operator. Simple example, suppose 1, 2, 3, 4 is a number. Okay, 1, 2, 3, 4 is a number. When I perform modulus operator with a 10, what will be the value? The value will be the 4, right? Value will be the 4. Then suppose 1, 2, 3 modulus 10, that means the value will be the 3. 1, 2 modulus 10, the value will be the 2. 1 modulus 10, the value will be the the 1. By that you can remember one thing, any number can modulus with a 10, it will results the last digit of that number. Suppose when we are dealing with the loops and the conditional statements, I am giving a question like count the how many digits in a number. Count the how many digits in a number. Then this is the one way of operation you have to be do at that moment. And suppose 1, 2, 3, 4, how can it become 1, 2, 3? 1, 2, 3, 4 is a number. How it will become as 1, 2, 3?
Also decimal numbers. Decimal numbers also.
For the decimal numbers. Decimal numbers division operation is different, right? So it will be the different. For the integers only, when you are performing modulus operator with a 10, then the result will be the 4. If you are performing for the decimal values, then it will give us the decimal last point, decimal last result, right? Suppose how can I made 1, 2, 3, 4 as a 1, 2, 3? Simply 1, 2, 3, 4 by 10. The quotient is 1, 2, 3, right? The quotient is 1, 2, 3, remainder is 4. Remainder you can get by the modulus operation, quotient you can get by the division operation, but it has to be stored with a int type. Otherwise it will be the 1, 2, 3.4. If you store with a integer only, it will be 1, 2, 3, or else it will be with a 1, 2, 3.4. These two operations using, you can perform the different coding questions. Calculate the how many digits in a number, sum of the digits in a number, multiply the digits in a number, and also check a number is a Armstrong number or not. Check a number is a strong number or not. Armstrong number is nothing but, suppose 153 is a Armstrong number. That means 1 cube plus 5 cube plus 3 cube. 1 cube is 1, 5 cube is 125, 3 cube is 27. The result will be the 153. Any number can be power every digit with the count of the digits power, then the number same will become, then it will be Armstrong number. Strong number is nothing but it will be depends on a factorial. 145 is a strong number. 1 factorial plus 4 factorial plus 5 factorial value. Sum will be the 145. Many programs you can do by using these two operators of the division and a modulus. When you are dealing with the competitive coding also, many programs are there on a numbers. It can be do by using these modulus operators. Okay. Simply you have to remember the modulus operator helps to getting the remainder values. Division operator sometimes getting the quotients, sometimes will be the exact values. Quotients when it will be get, you can store with the integer types, or you can convert the result with a integer typecasting. We are not discussing the typecasting, right? We can discuss. This is the thing with the arithmetic operators. First we can perform the arithmetic operators in a programmatic. Later we move to the other. I have to declare a main method. Public static void main string args. I have to read it two numbers. Okay. How can I read the two numbers? First I have to define a scanner class object. Suppose scanner as an object. It is anything, a name, only a name. New scanner. Here the capital S and the small s is the different. System dot in, and you have to import the package. Import java.util util.star you can use, or else you can directly import the same scanner class. Okay, both will be the fine. You want to perform an arithmetic operation, you have to read the integers or a floats. Any numeric values you have to read. Okay, suppose I can read an integer and one float. Okay, an integer and float. Int a, float b. Okay, simply sysout of enter a value and enter the b value. I can read the two things, and I have to perform an operation, right? Suppose if I take int c, okay, int c, here I can read the values of enter a value, a equals to scanner dot next int. By that I can read the a value, and in the b scanner dot next float, right? Suppose c equals to a plus b, c equals to a plus b. What is the error is a b. A is a type of float, b is a type a is a type of int, b is a type of float. A plus b will be the float value. A plus b when you are performing, it will be the float value, but you are try to store it in a integer value. Float is the higher data type, high preference data type. That high level data type you are not allowed to convert into the lower level data type. For that we have a explicit typecasting. Okay, we can know that in a typecasting concept. In a scenario, define this as a float. Okay, suppose I can declare this is a int, then is also it will be the take, but here also you have to change the int. That is the concept. C equals to a plus b, and sysout of addition result, anything, addition result simply text you can combine with a value, plus is the operator you have to use, but it will be changed in the concept of printf. You have to use the commas for printing the values. C. Okay, Control S and run the program. Where you can run, simply you can run here. Run Java. Okay, I am right in the relational operator class. I can enter a value of 12 and the value of 5. The result will be the 17.0. Why? Because I am taking the float, right? Because of that the value will be the float value. Suppose if you are not taking here the float, comment it. There are the two types of comments here. It is a single line comment. Double slash will be the single line comment. Comment is nothing but your compiler not take that statement to run. Okay, and multi-line comment means suppose you want to comment this all the thing. Okay, that means multiple lines you have to comment. You can use slash star and star slash. This is multi-line comment. Two types of comments you can use. Simply I can comment this and I make here as a plus b. Okay, it is one result, right? Here also now I can get the same as a float value. Why? Because taking the b as a float, so integer plus float, the overall result will be in a float. It was a implicit typecasting. That means your compiler implicitly converting one data type, lower level data type to the higher level data type. It is a implicit typecasting. We can discuss the typecasting concept. That is, for that scenario it will be the result. Okay, Control S. Run this. And the 5. The result is 125. Why? Because it will print 12 and 5, not multiply or any operation it will do. It will do simply concatenation. Do one thing, place the braces. Why? Because you have to print the result value, right? So one operation it has to perform. Suppose you are using the plus symbol, that means you are printing the result, you are printing the values. So in that scenario, I can run this, run Java code. 12 and the 5, 17.0. Careful, when you are printing the values of your operation, you have to use the parenthesis for that operation. Okay, right. Suppose you want to perform the minus operation, then you can simply change it to the minus. If you want to perform the multiplication, then you can change it to the star. Okay, change it to the star. When you want to perform the division operation, change it to the division. Here we can perform. Okay, 12 by 17. Okay, 12 and 17. The result is 0.7058824 up to 6 decimals. Why? Because it will print the float values. Okay, it will print the float values. Okay, we are not mentioning any data type, right? We are not mentioning any data type, so it will print the double. Simply I'll do one thing, uncomment this and uncomment this C equals to A by B, and here I can print the C. And 5. Okay, in before what I do, 12 by 17, right? Okay, I'll run this again. Run Java 12 and 17. Again 7 digits. Float has the precision. Okay. Double. We'll check once. Approximately 6 to 7 decimals. 6 to 7 decimals of accuracy. Because of that, 7 will be print. We'll do one thing. Right? If I performing the 12 by 17 operation, my result will be the 0.7058 like that. But I can end with the 7th digit as a 4. It will round up to the 24. So float has a precision. I am telling that as 6, it will be the 7. Some compilers it has a 6, some compilers it will be the 7. Depends on the version. Okay? Yeah, float has a precision. Right? Like the way, suppose you want to store it in a int C equals to A by B, then you can mention here the C. You can't convert or a type mismatch. Why? Because I already have a one float value. So it will be the result will be the float. It will not able to store it in a integer. I can store it into a int. Okay, int, and my result also in a int. Type mismatch. Okay. Running that Java code. I can enter a value of again the 12 and a 5. Then my result will be the 2. It will be the question. Why? Because I am storing it into a integer type. So because of that, it will take only the quotient value, avoids the remainder result. Suppose if I am not maintaining into the integer type, okay, I can directly print the A by B. Then my result will be the 2. What it will print? 2. Why? Because you are taking the only the integer and integer. So the result is also being a integer. Suppose you are taking a one int and one float, then the result will be the float. It will depends on the operands also. If you are both taking the 2, that means dividend and divisor, or both are the integer types, then it will be the integer result only. If one of it will be the float, then it will be the result will be also a float. Okay, that's the thing. For that scenario, I am mentioning that both are the ints. Clear? Next thing. These are the basic arithmetic operation. Next, modulus. Right? In the same scenario, I can go with the A modulus B. I can enter a value of 12 again and the 5 again. The result will be the 2, right? You can run this again. I can enter a 3 and the 2. The result will be the 1. You can use the comparison operator. You can check a number is an even or odd in this way. Okay? We have a conditional statements and the other relational operators and all things. Then you can easily find out. Modulus operator helps you getting the result. Okay? Fine. When you perform modulus with a 10, it will give the digit of the last digit in a number. Okay, remember the 10. Next, we can deal with a relational operators. Okay. Relational operators. Relational operators have only two outcomes as an output. I think right. Relational operators relational operators have only two outcomes. It will be the true or false. True or false. Relational operators perform or checking the relation between two operands or two variables. Okay, checking relation between two operands or variables. Two operands or a variables. Okay, what are the relational operators we have? Greater than, less than, same way, greater than or equals to, less than or equals to, and equals to, comma, not equals to. You can use in the relation and this also. You can use in the both. Why? Because if you want to check two numbers are not equal, then it's also the same thing, right? Relational operator not equals to. Suppose you want to check a number is, suppose I have two numbers, A equals to 10, comma B equals to 20. Which one is greater? B is greater. How can you say? You can say by observing, you know that 20 is greater than the 10. But how the compiler can know, right? It will have to perform one operation. Suppose you want to check, I can perform like A greater than B. A greater than B. A is greater than B or not? Not, right? So this operation result will be the false. Suppose if I perform B greater than A, then the result will be the true. Why? Because B greater than A. The same way, B greater than or equals to A. Observe the term, B greater than or equals to A. Greater than or equals to A. Greater than, right? B is greater than A.
Yes. True, sir.
True, right? So it is true. Here you are checking the two conditions. One was B is greater than A or else B is equal to A. You are checking the two conditions. In the same scenario, B is less than or equals to A. B is less than A or B is equal to A. Two conditions. The same way, B equals to A and B not equals to A. Suppose A equals to 10, B equals to 10, then B equals to B, true, or else false. The same way, A not equals to B. Here, if you are performing the A not equals to B, then the result is true. Why? Because A is not equals to B, right? So because of that, A is 10, B is 20. So both are not equal. Then the result will be the true. Suppose if you are performing A equals to B here, then the result is false. Why? Because both are not same. Convert this into a English terminology according to your knowledge, right? Greater than or equals to, in that you have a or, right? Or means what? This or that. The same way, B is greater than A or B is equal to A. You are checking the two conditions here involving of a logical operator. Okay. For a formality, we can write a program in a relational also. Okay, reading a two values, A equals to int A float B, right? Printing of A is greater than B. How can I check? A greater than B, right? Save and run this. Run Java. Okay, enter a value of suppose the same thing, 12, another 12. A is greater than B will be the false, but I am entering the both of the false. Why? Because not great, right? Both are the same, not great. Suppose if I am using the A greater than or equals to B, what will be my output for the same A equals to 12 and B equals to 12? My output will be the what is the output? Suppose 12, another 12. What will be my output? True. Why? Because greater than or equals to. Both are the 12s only, so equal to operation will be performed. A equals to B will be operation will perform, so the result is true. In the same way, you have to check for the A less than or equals to, A not equals to, the result will be the true or false. Okay, true or false. These two will be the outcomes of the operation in a relational. You have to remember that thing. Okay, suppose you want to check for the A is less than B, then you can write for the A less than B operation. Okay. If I giving tasks to perform on the relational operators, you have to write for the A is less than B as another print statement. You can perform A less than B. A greater than or equals to one operation, you can write another print statement, A greater than or equals to B, not equals to, and the equals to equals. Right? That's the way you have to write for the all the print statements. I am simply writing one print statement. You can write for the all print statements. Okay? Next. Logical operators. Logical operators are the three logical operators we have. What are the logical operators is perform operations on two expressions or the conditional values. on two expressions or conditional values. Do you know the difference between the expression and a equation, right? What is an expression? What is an equation? What is an expression and what is an equation? Suppose a plus b is there. Is it an expression or an equation? Huh? This is equation and this is expression. Expression have a no result, equation have a result. Okay? You are equating with a 0 or 1 or 2, it will be the equation. If you are not resulting to anything, it will be a expression. So like this you can perform or comparing two expressions or two conditional values or two results, anything. Logical operation compare helps to compare two expressions or conditional results. Okay, here you have a 3. One was the logical and, another thing was a logical or, another thing as a logical not. The symbols are for the AND operator double ampersand, for the OR operator where is the symbol here? Normally I have no symbol. Not no, not two slashes, two vertical lines, like this you have a two vertical lines. In my keyboard it is not there. Yeah, it's there. It is a UK keyboard, so the keys are the different. Fine. This is the symbol, OR symbol, logical OR symbol. For the NOT, this is the symbol. These two are the same, this is different. NOT operation you can perform on a single expression. Perform on a single expression result. Single expression result. Okay, these you can perform on a two expression results, but logical NOT will be comparing on a single expressions. Suppose you have two expressions. One expression is expression 1, another expression is expression 2. Okay, you have a two expressions, remember this. And what will be the outputs? I'll tell you. The output will be the, suppose, remember the things. Suppose first expression is true, first expression result is true. Okay, second expression result is false, then the output is also a false. Okay, suppose first one is false, second one is true, then it is also false. First is false and false, then the result is also false. Suppose true and the true, then the result is true. In the logical AND operation, if the both the results are true only, the final result will be the true, or else it will be the false one. So remember, both inputs are the two Okay, fine. So you have to remember the only single thing. If the both the inputs are true only, then the output will be the true, or else it will be the false. The same scenario, control C. Logical OR, for the same scenario, in the logical OR operation, if the one of the input is true, if one of the statement is true, then the result will be the true. If the both the statements false only, the output will be the false, or else all are the true. Okay, if both are the false only, it will be the false, remaining will be the true. Okay, and finally not operator. In the not operator, tap, control V. Sorry. In the not operator, only one expression is there and one output is there. Suppose it is false, then the result will be the true, vice versa. If it is true, then the result will be the false. Expression is true, output is false, expression is false, output is true. That means vice versa. Okay? Here, you have to check on it two conditions, right? Logical operators. Okay. I am reading two numbers. Okay, I am reading two numbers and the same int and the int C. Reading the three numbers. Okay, the same thing. Why this conditional operator helps to logical operator helps to is when you are performing with the control flow statements of the if else statements and all the things, then it will help to you. Enter C. Suppose you want to check which number is greater, then you want to print the result of A greater than B and A greater than C. Okay, A is greater than B comma C. True or false, you have to check, right? Run this Java code. Logical error.
System.
Suppose I can enter the A value of 10, B value as 4, C value as 16. A is greater than B, but A is not greater than C. So the result will be the false. Why? Because this statement is true. A greater than B statement is true, but A greater than C statement is false. A greater than statement is false. So true and false. The overall result will be the false, right? Among the three, you have to find which one is greater. Then this is the operation you have to perform, right? Suppose you can check OR, then what will be the result? True. Why? Because A greater than B is true. A greater than C is false, but one of the statement is true, right? So if one of the statement is true, or operation result will be the true. Same. Suppose you want to perform not, just simply, then the result will be, here the overall result is true, but for the true you are performing the not, so it will be false. Here, this is the way you are performing not operation on a single expression or single result. This is the entire thing is a single result you are performing on a single expression, right? This is the logical operators. This is a logical operators. You can do multiple. We can go forward. You can focus on that. Next thing, you have to understand the statement. Relational and logical are the interlinking. If you observe here, right, you are checking this. This is relational. This is one relational. These two you can combine. It will be logical with a logical. Two results you are combining. The same thing. You can. Next thing is a assignment operator. Assignment operator is nothing but you are writing a equals to b, or a equals to 10, or a equals to sc dot next int. Assignment operators, that all are. Assignment operator. Okay. In the assignment operator, equals to is an assignment operator. Simply you are writing a equals to 10, right? A equals to 10. 10 will be stored in a. Here you are using the assignment operator. Assignment operator always works from a right to left. In the assignment operators we have the some things of plus equals to, minus equals to, divided by equals to, star equals to, or else modulus equals to, or else greater than or equals to. We already seen less than or equals to. These are nothing but what that actual meaning is. We are calling these are as a shorthand operators. Calling it as a shorthand operators. Suppose a equals to a plus 5. Already a value is 10. Already a value is 10. Then what will be the result here? The result will be 15. Why? Because a value is 10 here and b value, that means 5. You are adding the 5. 10 plus 5 will be the 15. After this execution of the statement, a value becomes 15. Without writing this statement, you can simply write like a plus equals to 5. This expansion of the statement, this both are the same. Both are the same. A equal to a plus 5 and a plus equals to 5. Both are the same. Suppose a minus equals to 5, then a minus equals to 5. Okay. Suppose a by 5, you can write like that, or else you can write a equals to 5. Not only the numbers, you can use the variables also. Suppose b equals to 6 is there, you can use in place of 5 you can use the b also. A equals to a into b you have to store, then you can use like a star equals to b. Okay, simply you are using one number, in place of that I am using the variable. Shorthand operators are nothing but if you are using like this means a equals to a plus b or a equals to a by b. Okay, these are the result. These are calling as assignment operators. Assignment operators work from a right to left. This entire result will be assigned to the a. After performing this operation, it will be assigned to the A. Assignment operator works from right to left. Okay. Next, fifth one, unary operators, I think. Unary operators, my pronunciation is wrong. Unary operators, I think. In this, we are talking about incrementing and decrementing operators. There are two types in this. One was incrementing. Normally for incrementing, in the incrementing you have the pre-increment and a post-increment. Based on the increment and decrement operators, you are getting, suppose you are attending any interview outside, they are asking the pseudocodes. Simply they can give a raw code, and in the 4 options they can give the what will be the output of a code. Suppose if you are attending in a campus placements, they are conducting this, right? Pseudocodes, they are asking the result. In that they are asking based on the operators only, majorly on the operators. In that they are using the incrementing operators and the decrementing operators. Incrementing operators. Increment operators. We have two. One was pre-increment and post-increment. Pre-increment and the post-increment. The same way, decrement operators. Decrement operators. The way pre-decrement and post-decrement. Pre-decrement and a post-decrement. Suppose simply you have a variable of a equals to 10. Pre-increment is like a plus plus. Post-increment is like a plus plus a. And pre-decrement is like a minus minus. Post-decrement is like a Control C. This is pre-increment. This is post-increment. Minus minus A. Pre-increment and the post-increment, pre-decrement and the post-decrement. If you understand the one increment or the decrement, you can learn other one. Suppose I have a statements of simply a raw code a equals to 10, comma b equals to 5, a plus, okay, a plus. Okay, simply I can do the a plus plus and a plus plus a equals to a plus b and the a plus plus. If I print a here and also if I print a here, if I print a here and I can print a here, Here what will be the a value? 15. 15, right? And plus plus. Here it will be the, here it will be print 15. Okay, after the completion of the statement it will be increment. Suppose if I do like a 5 plus, okay, a equals to 5 plus a plus plus. Okay, what will be my result here? What will be the a value here? 5 plus a plus plus. 16. Here a value is 15, right? So a value is 15 plus 5, 20. 20 is the result. Suppose if I print a here, it will be the 16. Here I am using the post increment. First perform the operation, after that it will increment the value. Actually a value is 15. It will increment by 1 or decrement by 1. Unary operators, why we are calling it as unary operators? Because of it will increment by 1 or it will decrement by 1. Only by 1. Okay. Suppose in the post increment 5 plus 15. Why? Because you are performing the post increment. After completion of the statement only it will increment the result value. Okay, the same scenario. Okay, Control C, Control V. Here I am changing to the plus plus a. What will be my result here? Come from the top. Okay, what will be my result here? It will be a 21. Why? Because plus plus a. First it will be increment. The 15. A value is actually 15. 15 will be increment to the 16. 16 plus 5. It will be the 21. Here the a value will be 21. Understand? That means if you are using the post increment or the post decrement, the value will be reflected for the next statement. If you are using the pre-increment, in the exact statement only the value will be reflect. Okay, if you observe here in the post decrement or the post increment, the value of a will be reflected after the execution of the statement. But in the pre-increment, it will be reflect the value of a in this statement only. Okay. These are the two things we can do in a program, but here in the program we can do with a decrement operators. Unary operators. Main a equals to 6. Int a equals to 6, int b equals to 7, so sys out of b plus minus minus a. Right. What will be the result here? A value is 6, B value is 7. 7 plus 5. Why? Because it will decrement. Actually A value is 6, but I am using the pre-decrement. So in this statement only it will be do. If I using this as plus plus, then what will be, minus minus, what will be the result here? 13. Why? Because again I can print here as sys out of here I can just print a plus sorry, a plus b. Okay. What will be the result here? 12. Why? Because a value changes to the 5. So because of 5 plus 7, it will be there 12. $13, 12. The value in the post decrement reflected after the execution of this statement. First executes the statement, after the value will be reflected. But in the pre increments or the pre decrements, first the value will be reflect, after the statement will be the execute. Okay, clear? Right. These are the operators we have. Okay, but the major operator, one thing we have to be discuss. Ternary operator. Ternary operator. Ternary operator is nothing but a like a one if else statement. Ternary operator is like a if else, but it is one operator. Simply I can tell the ternary operator here. Okay, suppose I want to check A is even or odd. Okay, I want to check A is even or odd. How can I tell A is an even? If I perform A modulus 2, the result is 0, then the number is even, or else odd, right? Then simply result A modulus 2. A modulus 2. This result you are comparing with a 0, right? So this is the result of the perform equals 0. Okay, this is the conditional operator. If the condition true, print this, else print this. If condition true, res value will be the even. If condition false, res value will be the odd. Okay, it is a ternary operator, normally like a if else, simply if else. Conditional ternary operator, question mark and the colon. If this condition is true, then it will be even or else false. Suppose I want to check a number is odd or not, then you can check A mod 2 equals to 1, then odd. Why? Because if this condition is true, this statement will be the value. If the condition is false only, this will be the value. Okay, this condition is true, this will be taken into the consideration, or else this will taken into the consideration as a res value. What will be my value? Now it will be print odd, it will be print, sorry, even it will be print. Why? Because 6 modulus 2 not equals to 1. So this condition is false, so this statement will be execute. Suppose I want to check A is greater than 0, then what can you do? Simply you can change this condition to the A greater than 0. If A greater than 0, it is positive. If A greater than 0, it is positive. Or else negative. I can read a number. If it will be greater than 0, it will be takes res into the positive, or else it will be negative. This is ternary operator. Simple if else statement. Okay. Next major thing. Sixth one as a ternary operator. Okay. Ternary operator. For that, take this as an example. Okay. Seventh major thing, bitwise operators. These are interesting and difficult. Not actually difficult. If you are focused, it will be understood. Normally, everything can be stored in a form of bits. Suppose if you are writing like a equals to 10 also, in your system it will be stored it as a bits. In your system it will store it as a bits. Okay. So, how it will be stored it as a bits? And what will be the bitwise operations you can do? Fine. What are the bitwise operations we have? Before going to that, all of you can know how can you convert an integer into a binary format. We have a number formats. One was a decimal, another thing was a binary, hexadecimal, octal. Decimal, hexadecimal, octal. Normally now we can focus on the decimal and the binary. Okay, decimal and the binary. I think most of you don't know how to convert a number to the binary. Suppose 0 is there, the 0 binary value is a 000 or simply 0. It depends on a bit. Suppose it will be a 3-bit value, then it will be a 000. It will be a 4-bit, it will be a 4 zeros. The binary value of 1 is suppose I am taking the 4-bit, then 0001. Binary value of 2 is 0010. Okay. Binary value of 3 is 0011. Okay. Binary value of 4 is 0100. Okay. Simply 5 0101. Next 6 0110. 7 0111. 8 1111. Sorry, 1000. 9 1000. 1001. Simply you can observe the pattern. Okay, you can observe the pattern. For 0 it is 0, for the 1 it is 1, for the 2 it is 10, for 3 it is 11, for 4 it is 100, for 5 it is 101, for 6 it is 110, for 7 it is 111, for 8 it is 1000, for 9 it is if you observe 0 1, right, for the 2 1 0, for the 3 1 1, right, for the 4 1 0 0, like a 00, for the 4, for the 5 101. Normally how it is like a, suppose 3 means 3 is like a 2 plus 1, 3 is like a 2 plus 1, 2 value is 10, so 10 plus 0, it will be the 100, right. 3 is 4 is 2 plus 2, 4 is 2 plus 2, but you can't write like a 1010. 2 is the 2 power 1, okay, it is 2 power 0, 2 power 1, 2 square, 2 cube. You can observe the 1 at the 2 powers. Normally how it will get is You all know the division, right? I can check, I can find one number. Suppose I want to check for the 10 binary value. 10 binary value is 1010. But how you can get is simply 10 okay, divide it with a 2. Binary values will be a 2. What will be the result? 5. What was the remainder? 0, right? Next, divide this is also with a 2. What will be the result? 2 2s are 4. What will be the remainder? 1, right? Simply. Next, 2 1s are 2. What will be the remainder? 0. This 1010 will be the 10 value. Come from here. 1010. This is the 10 binary value. This we are calling it as a LSB, I think. LSB, least significant bit, and it is as a MSB. LSB and MSB. Okay. Normally you can find the binary values like this way for everything till you have to perform this. Result will be the 0 or else it will be the 1 and come to from this. Okay, and you can observe the easily pattern 00 01. Take these 3 as into your mind. Okay, next from the 4 is the 2 square, so 2 power 2, so 2 power 2 is the 4. So here will be the 1 and the 0 will be the repeat. Next 5 will be the 1 will be repeat, this 0 1, 1 will be repeat and 1 0 and 1 will be repeat 1 1. Why I am taking 1 byte as a 7? Why you are taking 2 power 7 and 2 power 7 in the range of byte is because of this 0 1 2 3 4 5 6 7. These 8 bits considered as a 1 byte. And also if you observe here, by using the binary number you can find the decimal. It is a 2 power 0. It is from the 0th bit. Okay, 1 bit, 2 bit, 3 bit. 2 power 0 plus 2 power 1 plus 2 square plus 2 cube. 2 cube value is 8 plus, normally how it will like is 1 into 2 cube, 1 into 2 cube or 2 power. Okay, plus 1 into 2 cube plus 0 into anything will be the 0. So 0 into 2 square plus 1 into 2 power 1, right, plus 0 into 2 power 0. 2 power 0 value is 1, 2 power 1 value is 2, that means here you have a 2, and also 2 plus here 2 and here 8 plus 2 10. That is the way. So if it will be the 8 bits, that will be end with a 2 power 7. Okay, right. And remember one thing here. What is the LSB here? I think it is LSB 0, right? What is the LSB here? 0. What is the LSB here? You can observe one pattern. All even numbers have the LSB as 0. By using the bitwise operator also you can tell a number is even or odd. Okay, all the even numbers have the LSB as 0, all the odd numbers have the LSB as 1. Okay, remember the thing. Why? Because when you are dealing with the remaining operators, I can tell how it will be. Okay, first one, it was a bitwise and the operator is this one. Okay, simply taking the example of a equals to any number 5, comma b equals to 11. You want to perform a and b. Okay, a and b. Suppose you want to perform a and b, then suppose you want to perform a and b, what will be the result? Is normally a value is a binary value is 5, right? So 0 1 1 101 is a binary value. I am taking as a 4 bit. Why? Because 11 will be the 4 bit. So for that scenario, b value as b as 11, right? So 8 plus 3 1 0 1 1 1 0 1 1 8 plus 3. Okay, for the C, sorry, C is not there, right? Suppose if you perform A and B, what will be the result is, first you want to know the truth table of an AND operator. A, B, what will be the output? Same like a logical operator. Suppose A value is 0, B value is 0, output is 0. A is 1, B is 0, output is 0. A is 0, B is 1, output is 0. If both the inputs are true, then the output is 1. Okay? Same way. Now you can easily tell 1 and 1 value will be 0. Okay, 1 and 1 value will be 0. 1 and 1. Okay, carry will be forward. Here it will be the 1. Okay, carry will be forward. 1 here. Normal 1 1 means 1 0. Carry will be forward. 1 1 1 0 again. Malli carry will be forward. Carry will be forward. It will be the 1 1 4 zeros. That means 16. Wait a minute. In the AND operation, I think carry not forward. I'll check it once. What we are taking 5 and 11, right? 5 and 11. Run this. Run Java. Okay, it will print 1. Carry will not forward. Carry not forward. 1 and 1. 1 will be the result. 0 and 1. 0. Okay, will come from right. It is 0 and 1. It will be 0, 1 0 0, 0 1 0, 1 1 1. Then the result will be 1. Carry not forward. In some scenarios, carry will be forward. When you are using the office operator, there are the different concept. Okay. This is the concept. If both the inputs are the true, then will be the 1, or else it will be the false. Okay. Same for the OR operator, bitwise OR. Bitwise OR operator. Symbol of single slash. Okay, bitwise OR operator. The same like here. Now you can easily find the truth table of the bitwise OR. What will be it? If one of the input is true, then so here 0, remaining all will be the 1, right? Simply take the example of AB. Take the example of AB only. Hmm. 0 1. What will be output? 1 1 0 1 0 1 1 0 1 1 1. It will be 1. 4 ones means it will be the 15. It will be the 15. You check it. Uh, 5 or 11. What is the value? 15, right? You have to know the truth table. That's all. And bits conversion. Okay, fine. Next, bitwise not. Bitwise not operator. The operator is this one. Okay, it will be performed on only one number. Suppose a is a equals to, for a equals to 0 1 0 1. Okay, 0 1 0 1. Suppose you want to know the output of a not a, output of the not a, then here it is 0, right? The 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0. What will be the result? 10. 10 will be the result. 0 becomes 1, 1 becomes 0. That is the truth table. The same AB and the output 0, sorry, only 1, right? Only one input. If it is 0, then it is output is 1. If it is 1, then the output is 0. Two scenarios only. Okay. Next, XOR. XOR. The operator is this one. XOR. XOR. Okay. Fine. XOR. In this, the truth table is, it is like if both inputs are not matched, then it will be true, or else it will be false. Okay, if the both inputs are not true, suppose 0 and 0, then the output is 0. Why? Because both inputs are the same, right? Because of that, it was 0 and 1, then it is 1. Suppose 1 and 0, then also 1. Why? Because both are not same. If 1 and 1, then it will be 0. If both the inputs are dislike, then it will be true, or else it will be false. Okay. Next, left shift and right shift, and right shift. Left shift and right shift. This left shift symbol is this one. Right shift symbol is this one. Okay, suppose a is the value, a equals to 10, the binary value is 1010, right? Suppose I want to perform a left shift of 1. Simply what you have to do is left shift this bit 1. Okay, simply add the 10 at the last. Why? Because it is 1 bit. What will be the value is 1010 and add 10 here. Simply shift this in the left side and add the 10. Suppose if you are dealing with a 2, then add the another 0, 2 zeros at the left. Suppose if you are dealing with a 3, then add the 3 zeros. Okay, simply I can explain with the 2 zeros. What is the value? 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. 2 power 4 value 64. 64 plus 4, 68. ఇంకో 0 ఉండాలిగా. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. 2 power 5 value 32. 2 power 4 16. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 cube 18. 32 plus 8, 40. 10 into 2 power 2. 10 into 4, 40, right? 10 into 2 power 2. Suppose if I do with the 10 cube, then my result will be the 80. How can I say it is? What is the value I have? 10, right? 10 into 2 cube. Suppose if I shift with a 4, then 2 power 4 will be the 16. 16 into 10, 160, my result. Okay? If you are performing a left shift operation, then it is multiply the value with a 2 power of the bit shifting. Okay, 2 power of the bit shifting. In the same way, right shift operator, the same for the right shift. Control C. Now you can add the zeros at the right side. Suppose a right shift 2, then you can add the zeros at the 0010, removing this slash 2 and add this 2 zeros in the front. MSB side it will be increase, but LSB side it will not. That's why you have to remove this. Why? Because beyond the 2 power 0 it will not anything, right? So that's the scenario. How many bits you are shifting? Remove that much of digits here and add the zeros in the left side. Then here the result will be the 2. Actually here it will be multiply, right? Here it will be divide. Here it will be divide. Suppose a equals to 8, I can do. A equals to 8. 1010. 8 value is 1000, right? Right shift of 2. The result will be the 10, I think. Why? Because 2 power 2, 4. 8 by 4, 2. That is the result. It is internally working. If you are printing the statement, the result it will be print in the console is 2 only. It will not print 10. Okay, it will not print 10. It will print 2. This is the right shift and the left shift. Okay, simply tell me one thing. I have a number of 1010. It is a 10 value, right? Perform AND with a 1. Perform AND with a 1. What will be the result? Perform AND with 1 means what will be the result if you are performing AND operation? 0 0 0 0. What will be the result? 0, right? Okay, I have a 111. Perform AND operation with the 111. What will be the result? 0 0 1, right? By this you can conclude one thing: if you perform bitwise AND operation with any number with 1, the result is 0, then it is an even number, or else it is a odd number. Okay, 10 and 1, if the result is 0, then it is even. If it is 1, then it will be odd. Okay, for the odd number the result is 1, for the even number the result is 0. This is the way you can perform the even numbers also for the checking. Okay, this is the thing with the bitwise operators. Simply I think suppose you are from a computer background, or else if you are familiar with any other programming language in your academics or in your college, they can give a first one question is swapping of a two numbers, right? How can you swap a two numbers? Suppose a equals to 10, b equals to 20, or 20. Okay, if I print a b, if I print a and b, my result is print like a 20 and 30. That means in place of a it has to print 20, in place of b it has to print 10. Okay, how can you swap two numbers? One way, by using a temporary variable. By using a temporary variable, I can take one temporary variable c equals to a. Okay, c equals to a. That means in place of a, what will be the what is the value of c? 10, right? Okay, value of a is c is 10. Change a equals to b, then what is the value of a? 20. Again change the b equals to c, right? What will be the result? 10. If I print a, what will be the value? 20. If I print b, what will be the value? 10. Swapping the two numbers, right? This is using a temporary variable. One way. Another way, without using temporary variable. Without using a temporary variable, you can do it in a two ways. One by using the arithmetic operator, one by using the XOR operator. First, you can see how can you do by using the arithmetic operator. Suppose a equals to 10, b equals to 20, the same thing. Simply do a equals to a plus b. Okay, what will be the result here? 30, right? What will be the result here? 30. Fine. Next, a equals to a minus b. 30 minus b equals to a minus b. What will be the result of b? 20, right? 30 minus 10 will be the b value. Why? Because a is 30, b is 20. So 30 minus 20 will be the 10. Again a equals to a minus b. What is the value of a here? 30. 30 minus 20. 30 minus 10. B value changes to 10, right? It will be the 20. It is without using a temporary variable. Another thing, by using the XOR operations. By using the XOR operator. Okay, a equal to a XOR b. Okay, a equal to a XOR b. What is the binary value of a? 10, right? 10 means 0 1 0. For the 20 it was 16 plus 4, I think 1 1 0 0. 16 plus 4. Okay, it is the value. Suppose XOR means if both the inputs are different, then only, right? 1 0 0 1 0. It is 2. It is 2 power 0, 2 power 1, 2 cube, 2 4, 2 5, 33, 34, 34. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. 2 power 4 is 16 plus 2. 16 plus 2. Okay, 16, 2 power 1, 2. 16 plus 2, 18. Suppose it is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. 2 power 4 is okay. 2 power 4 is it is 4. Sorry, it was a this is okay. Now the value will be changed. So 0 1 will be the 1 1 1 1 0, right? Now the result will be the 2 power 1 2. That means this is as a 14 plus 32. Adena 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. 2 power 4 is 16. 16 plus 14, 30, right? 16 plus 14, 30. So if I perform A XOR B, here the A value will be, what is the A value? 30. A value is 30. Next, B equals to A XOR B. Sorry, again A equals to A XOR B. Okay, 30. It is the 30 value, right? 30 XOR what is the B value? Again the same. One 0 0 1 1 0 0. Sorry, 1 1 0 0 1 1 0. It will be 10. So B equals to A XOR B. 10 has to be stored in B, right? So here it will be 10. Again A equals to A XOR B. Okay, what is the A value? A value is 30 again. A value is 30 again. B value is 10. Then you can get that one. 101 110 101 110 000. It will be 20. It will be again 20. This is the way you can change in a other way. Okay, fine. This is all about the